All right, I'm going to attempt to do a brief walkthrough of the circuit simulation. This is one of the more complicated ones, so there will be a bunch of things I kind of gloss over. I've tried to add comments in all the different sections if you're really interested in the very particulars of what's going on. So the code starts up here with all of the setup, a lot of the variables that you're going to allow the users to change. I'm actually using an array here of points. These are two-dimensional vertices. And I use an edge, a list of edges, to keep track of all the things that go from one to the other. The battery voltage, that's also set up here. And so all of this is doing is it's setting up arrays of edges where I'd say what the two vertices of a particular edge are and what kind of thing it is, as well as any variables I set up. I begin to do more of the true and false values. And then this actually sets up the original grid. So I set up all my edges, I set up where my battery is, fonts, setting up all the things having to do with short circuits. So I run these three quick checks where I say, check for any wires that are unattached. So if I have two separate circles of wires, I check for that. Check for dead ends. So if I have a wire that leads off and doesn't rejoin the circuit, and I check for short circuits. So I try and walk a path through the entire thing and check to see if there's any spot where I have zero resistance, because that breaks everything. If I don't have a short circuit, I calculate the voltage, which I'll get into later, and then I set up the 3D. Now before I go into the specifics, there's a bunch of variables that are set up. There's some classes I want to show you at the very bottom. So let's see, here we go. So a vertex is one of those points that is in the grid. So it has voltage, current, edges, and it keeps track of the x and y position. So this is just holding information about a vertex. Edge, this checks whether or not you're a battery, a wire, or a resistor, and keeps track of all the information about that particular kind of edge. Positrons, so those little dots that are in the grid on the 3D simulation, those are called positrons because they're flowing in the positive direction, which is not how electrons would. It's not technically which other thing people would call a positron, but it made sense to me. This has to do with where that's located in the 3D grid and whether that's being drawn. And the final class is this thing called a change. There's a history of changes. In order to make the simulation work, I had to do resistor reduction, which means I pulled out two resistors in series, replaced them with the corresponding one, pulled out two resistors in parallel, or multiple resistors in parallel, changed those with the corresponding ones, and so on. So I had to create a history of all these changes I made so I could undo them later. All right. So back up here at the top, when I'm drawing, I draw my 2D components, my grid, and then I draw my 3D simulation after that. If there's an issue with reducing, for whatever reason it's an unreducible circuit, which there are a few of, I just say I can't reduce it. The 2D grid walks through my array of vertices and then all of my edges, and basically draws all the circles and 2D components that it's composed of. So vertices are these ellipses. The 2D components are all my resistors, batteries, all that stuff. And a lot of this stuff has to do with drawing things associated with that. So current direction with triangles, drawing lines for the particular wires I'm drawing, whether or not I'm drawing the battery. So this is having to do with drawing the plus and minus of a battery. So all of this has to do with drawing the two-dimensional grid, horizontal resistors, vertical resistors, exactly where that's located. I ended up using a lot of variables to keep track of where the beginnings and ends of things were so that I could change, for example, this horizontal offset up at the top and have it change throughout my code, rather than hunting down everywhere I used a particular number. Three-dimensional simulation, I have to walk through and find all of the places where the positrons go. So I need to figure out, okay, where are all of the places where the walls need to go? Where do those little quadrilaterals that are the tops of the columns go? All of that kind of stuff goes here. And then I need to figure out where all those little balls, the positrons, going to be. When I'm actually drawing it, that's where I basically find all of those places that I calculated beforehand. I pre-calculate the x and y positions of all of those different pieces of that three-dimensional grid and then draw them. So I draw all my walls, I draw my squares, I draw my walls to the right and left, that kind of stuff. Here's the methods for checking dead ends and all of that, short circuits, pathfinding, so on. For those of you that are interested in computer science, I do a depth-first search in order to figure out for short circuits. And then comes this monster. So calculating the voltage. This is where I walk through the entire array of edges. I remove all the wires, and anything that was attached to a wire, I merge those two vertices. Then I walk through all my resistors, and I take out everything that's in series and replace them with a single resistor. Then I take out everything that's in parallel, so checking for parallel, and remove those, replace it with the equivalent resistor. And I basically continue to do that over and over again until I'm down to just one battery and one resistor. Once I do that, I have to then backtrack back through my circuit and figure out, okay, if the thing I removed was a resistor in series, calculate the corresponding voltage across them, because current will be the same, but voltage will change. If I remove something in parallel, then the current will stay, or the voltage will stay constant across them, and the current will change through them. If I have wires, how do I calculate those? And there's probably a better way to do this, but I'm basically manually adding up points that wires go into and out of and trying to calculate where the current goes and what direction it should go through that. So that's what all of this has to do with, is calculating which direction current is going, whether or not, what the voltage and the current through each of those different things should be. And then once I have done all of that, so I make sure I transfer all my currents from that thing that I just calculated, that whole history of possible changes. And then I also calculate for all my dead ends, just passing along the voltage. So all of that is how the circuit simulation works.